So in this video, we look at a longitudinal data set and get to know some more functions and then combine all of them together in a quite powerful but compact set of commands to deal with data. Here in our toy data set, you can see we have an ID variable, we have a gender variable, we have a time variable, so you can see it's repeating 3 times, and then we have coping and stress and just an additional variable with a funny name. Read the data set in, and now we go through different kind of examples. And you can see here we have filter and select. So we want to select some rows but nothing where the ID is smaller than 3. And we want to select only some columns but not all the funny variable we want to drop. You're already aware of that, so this is just a short repetition. Okay, let's run it and see what happens. And drop the last column. So that worked. Then the next step is, and sometimes that's important, we want to just add a row count. So on a variable that just counts our rows. You can see that adds at the end the row count. Now we can see we have 13 rows. Sometimes that's very helpful. In the third example, we get to know a very important function, and that's group underscore by. And group underscore by, as you can see the definition, takes an existing data frame and converts it into a group data frame where we can operate anything we want on these particular groups. So here the idea is I want to do a computation for each participant, but the idea is for couple, and so in order to reach each individual person, I have to specify here the couple ID. But I cannot just use the couple ID because that would give me a mean from both partners' average, and also have to say and separated per gender. So if I look at the couple ID and gender, then I know that would be specific for each individual person. This is an extremely useful function when we want to do something in particular groups. So that can be in a multi-group, that can be when we have here longitudinal data. And I want to do something simple first. I just want to compute the mean score for both of these variables over the time. So let's run this here. And let's see if that's true for the person 1. So we look at the first person has the first 3 rows. Let's look at coping. So we have 3.7, 3.9, the average is 3.7, and you can see we get that for all the time points, we get the mean. And so the mean score was successful. Now in the next step, and that's something which is combined with the last example. So what we want to do here is compute the deviation. So we are using the coping variable at each time point and subtract the mean. So this means here as a variable we have the situation specific difference to the mean score. So again we use the group by function for each individual person and say I want to compute the deviation of coping and stress from the individual mean. Let's run this. And now let's have a look if that is true. So here we start with coping, which is 3.5, and look what is the average. So the average is 3.7. So this means at this moment the person is 0.2 steps lower than on the average. And then if you look at the difference score, you can see it's minus 0.2. So that is correct. That means the difference plus the average should give the original value. So this is something which is quite common if you have like intensive longitudinal data. So the next step we already know, this is how to standardize variables, now also on an individual level. I just run it so that you can see now we standardize that for each individual person. So here is an idea how to compute leads or lags. This means, for example, if you have a daily diary study, if I want to analyze how the stress I perceive today affects the coping of my partner the next day, then we have to compute either a lead or a lag. And that's what this part is about. So here the function we are using is lead. And when we look at the data set, you will see that it shifts the value in one row to the next row. And then just to show what you could do as an idea, which I'm not sure that's super useful, but we can now use this lead and subtract the coping at this particular day, and that would be the difference from coping from today and tomorrow. And then here for stress too. So just let's have a look at that. So let's have a look at the second person. So we have here for coping 3 values. Let's see what happens if we use a lead. That means here the data point from day 3 should be moved to day 2. And you can see that's what happens here. So the 2.8 is moved 1 row upwards, and the 3.1 is also moved upwards. And now you can see what happens with the 2.9. It disappears, because what you don't want is to put the 2.9 here into the next person. So there is no lag for day 3 because we don't have a day 4. So on the day 3 we have a missing. But if we would not use the group by command, then the 2.9 would be moved also 1 row up into the next person. And so we don't want that. So here again, the group by command is very important. And here as the example number 8, we have again the way how we compute variables. So this is nothing new. Then this is a way how I would, so here I show you how I would build up my data manipulation. So I would work step by step through. I would not just write it out, but I write out the first 2 lines. Then I run them. And if I see the work, then I work on the next step and next step and next step. And you can see here how useful that pipe operator is. So we can say, okay, take our raw data set, but we want to filter it because some of the rows are not okay. So drop them. Then we can rename some of the variables if they're not correct. We can select some of the columns because if we have a huge data set, maybe we don't need that. Then we want to include, for example, row names. We will want to compute new variables overall. And then we use the group by function. Now all this mutate here is group specific. And the group is here defined by couple idea and the gender, which means for one particular person. So in a way the group is here one person, but we have multiple data points nested in this one person. Then we use mutate, and you can see we compute mean scores, we compute the different scores, we compute a lead, and we compute here a different score between the coping on a particular day and the lead. So that can be interesting for some analysis. Then we can standardize some of the variables, and here at the end I included another row number, but this is now for each person individually. So let's run that all together. We discussed most of that already. Just look at the last row counts. You can see now this is 1, 2, 3, 1, 2, 3. And if you compare that with the count we had at the beginning, then you can see here if you don't use the group by, then it just counts all through up to the last person in the data set. So just to summarize, I wanted to show you how extremely flexible and powerful dplyr is. And this is just a code of hardly 18 rows. So in a way this is super short, but we have done really a lot. The first point I want to make is that if you understand dplyr, you can really solve most problems you ever face in data science. And that's what dplyr was designed to handle complex data in a quite efficient way. The second thing is you have the pipe, which I think makes it really great to write syntax in a quite human-centered way. We can just look at the functions, and if you understand the functions, then you can read it like text and you can say, okay, I filter first, then I mutate, I compute variables, but then I want to make subgroups, and then I do the analysis for the subgroup, and so on. It goes really step by step, logical forward. I think that's fantastic. And then we can say it is extremely efficient. So this is, what is this, around 18 rows of code. So it is very short, but we have really done a lot. I would say if you work a lot with data, this is really an ideal way. I think the negative side is if you don't do a lot of data analysis, then you often forget things. And so that's maybe then a little bit more problematic. That's why I think you find most of the commands here all together combined. And if you miss something, just have a look. And if you figure out something else which you use very often, just add it into the syntax that you build up all these skills step by step, and if you use it later on, you have it all combined together.